All right. So I think I start every video with all right. But anyways, we're going to move on to the next set of notes. We're going to be talking about the water cycle. Okay. I know many of you have probably studied the water cycle before, especially if you were here for fourth grade, you've mentioned it. But we're going to go through it again and talk about how each of those pieces kind of relates to what we've been talking about with the earth and the atmosphere and air and how all of that kind of works together. So make sure you have your notes number 6 in front of you, and we'll go ahead and get started. What is the water cycle? Definition for water cycle. The water cycle is the continuous movement of water between the surface of the earth and the atmosphere. Okay. And what we mean by that is this. In all probability, the glass of water that you're drinking today contains a molecule of water that Julius Caesar swallowed over 2,000 years ago, and another that a Tyrannosaurus Rex slurped up over 65 million years ago. Now, there's some debate over how long ago that actually was. I don't think I would say it was 65 million, but that's from the Foss Tea Tradition book. But the point is that there is never any new water created on the earth at all. The only water that we have is what we have, okay? So the amount of water molecules that existed on the earth back during Julius Caesar's time is the exact same amount of water that we have now. Okay, it is very probable that the molecule of water in my cup right here is the same molecule of water that has been swallowed by someone else. Okay, it's just gone through the system of either it was used by their body or it was exhaled through the vapor of their breath, or maybe it was excreted through the restroom and gone through a purification process and all these things. But I love telling students that because this is the kind of face I get. Okay. They're like, what? This molecule of water has already been drank? Yeah. Or drunk, whatever the word is. Yes. Okay. All molecules of water existed back when the earth was first created, and there's never any new ones. They're just continually cycled and reused over and over again. Okay. So the water cycle is the process of that. It's how we use all the water that we have, and then how it gets kind of cycled through and then replaced over and over again. Big part of the water cycle is gravity. Okay, gravity is a force that is at work in the water cycle as well, as it pulls the water not only down from the clouds down to the earth, but it also pulls a lot of the runoff water downhill in rivers and streams, and eventually causes it to flow out to the ocean. Okay, that's where all of our water ends up pooling eventually. Now, the water cycle happens because of 3 repeating processes, and we're going to talk about each one of these. Evaporation, condensation, and precipitation. Okay, make sure you write those in your the blank in your notes there. The water cycle happens because of 3 repeating processes: evaporation, condensation, and precipitation. So here's kind of an overview of the water cycle. I'm going to go through it real quick with you, and then we're going to take notes. It's easiest if I just explain it all at one time, okay? So let's start with the precipitation, what most people are familiar with. Remember how I mentioned yesterday in our weather notes that snow is also a type of precipitation, okay? And that is true. Precipitation is technically, by definition, any form of water, frozen, solid, slushy, whatever, that falls from the sky to the earth. So here we have 2 types of precipitation shown in the picture. We have rain over here on this side and snow on this side. Okay, so precipitation is the water coming from the sky down to the earth in some form. Then we do have a little bit of runoff here. This just means the water runs down the hill. We also have some water that just pools on the ground. Obviously, it's not like it just rains here and not over here all the time. So we have the combination of runoff and groundwater contributes to the ponds, the streams, and the lakes. Okay. And then as that water is heated by the sun and it gets hotter and hotter, we'll talk about on an atomic level how this happens, but this is where evaporation is happening. A good way to think of evaporation, a good example of this, is when it rains outside. Obviously, if it's raining for a long time, we get lots of puddles that kind of pool up on concrete or on the grass or things like that. Over time, those puddles disappear. And it's not because they sink down into the asphalt or into the concrete. It's maybe a little bit of that. But the biggest part of it is when the water gets heated up, eventually it begins to turn into steam. and it kind of evaporates up off the ground. Same thing that happens when you begin to boil a pot of water. If you put on a pot of water to boil on the stove, or a parent does, don't recommend you do that by yourself, but if you leave it boiling for a long enough period of time, eventually you will boil all the water out of the pot. All of the water will have evaporated into the air and will no longer be liquid water just sitting in the pot bubbling. Okay, so that's evaporation that happens in in nature naturally. Evaporation from lakes, streams, oceans, ponds, puddles, all of the above. So the evaporation happens, the water is kind of steaming up. Think of it like a boiling pot of water. The vapor comes up into the air, and then as the warm air rises with the water molecules in it, like fog, we get what we call condensation. Okay, condensation is where, as that air gets higher and higher up into the atmosphere, it begins to cool, and as that hot air begins to cool off, the water molecules that had evaporated into steam, they cool off and come back together to form water droplets. Okay, it's like those water droplets turned into almost like a fog, and then as you cool the fog off, it comes back together into like a drop of water. After enough water has condensated and enough water droplets have formed in the sky, then we get clouds. Okay, and as more and more water condenses, the clouds get bigger and bigger. Now we're back here to the clouds get too heavy with all the water in them, and then it rains again, and we get the rainfall, the precipitation. Okay, so that's the cycle. Precipitation, the water comes down, we get the runoff, the groundwater, the water heats up, it evaporates back into the sky. Then once in the sky, it cools off in the clouds and condenses back into water droplets. The clouds get too heavy, the water falls again, then we're back to the beginning. Okay? Earth's water. Most of Earth's water is salt water, okay, which is pretty common. If you look at our globe and kind of spin it around, you'll find that most of the globe is blue. That's because our Earth is I want to say it's like 75% covered in water. But anyways, all of the water in the ocean is salt water. So the majority of it is salty. There's only less than 3% of Earth's water is fresh water. Okay, that's the kind of water that we drink, right? So it's kind of mind-blowing to think there's only 3% of that naturally. But we obviously now have developed purification processes and things to give us a little more access. And then of that fresh water, about 70% of the fresh water, so 70% of that little itty bitty 3% is frozen in ice caps and glaciers. So this diagram here gives you a pretty good idea of what I'm talking about. So here in the red, we have all the salt water that's on the surface of the earth. Okay, the circle represents all the water. The red part of the circle is salt water. The green part of the circle is frozen fresh water. And then this little tiny sliver that we really can't even see is, if you were to zoom in and separate this out, okay, 0.045% of fresh water is underground, and then only 0.015% is on the surface. Okay, this lesson tends to make me really thirsty, because when I think about this is the only water that I have access to that's on the surface that's fresh. Okay, now thankfully we have machinery and we've engineered technology that can help get some of this water and this water and this water, okay, and freshen it so that we can then drink it and use it for our bodies or cooking or showering or whatever. But still, this is the only amount that exists naturally. Okay, so it's kind of crazy when you think about how little water is naturally available for us to just drink readily. Most of it's salty, first of all. Then of the one that's fresh, the biggest chunk of it's frozen, and then even of a little bit that's not frozen, part of it's underground. So makes it a little difficult for us. There's another pie chart for you. This big blue circle, the light blue circle, is showing you that 97% of it is salt water. This green sliver, the 2% is ice, and then the dark blue sliver, the 1%, is the fresh water. So first process is evaporation. Okay, the technical definition for evaporation: this is the process in which liquid water changes into invisible water vapor. What causes this to happen is the heat from the sunlight. So the sunlight shines into let's take a pond, for example, or even a puddle, begins to heat up that water. doesn't cause it to boil all the way, but it still causes the top layer to get hot enough to where it begins to kind of steam up and evaporate. And eventually the whole puddle has steamed and it's now gone. That would be evaporation. So evaporation is liquid to gas. Okay, water vapor is a gas, meaning it kind of floats through the air, just like steam if you're boiling a pot of water on the stove. Evaporation is the process of liquid to gas. All right. Now, these three pictures. Let me get my pointer again. So here's the pot of water boiling on the stove. This is the evaporation, the steam that I was talking about. You can see it a little bit here on the concrete and especially here with the hot tub. All right. But I want to talk for a minute about this picture up here. Okay. What you see here, this little guy, looks like it's got two little orange knobs coming off a big blue circle. Okay. This is the molecular shape of one molecule of water. Okay. You can't see this with a naked eye. You'd have to have a microscope. In fact, one droplet, like one little tiny raindrop of water, has tons and tons and tons of these molecules in it. But what happens with evaporation, liquid water has all of these molecules of water closely stuck together. Okay. When you add heat to this liquid water, okay, so for example, let's take the boiling pot again. When you begin, these are the water what the water molecules look like when you first put the liquid into the pot. It's not hot yet, you're just filling it up from the sink. When you go to put it on the stove and you add heat, what you're doing is you cause these molecules to begin to vibrate, kind of like this. They begin shaking a little bit. The more heat that you add, the more they move. And then eventually there's so much heat and they're moving so fast that they eventually just break free from the liquid altogether and float up into the air. Okay, so here we have the liquid molecules, like I mentioned. Once you add heat to them, the molecules begin to shake and move around. If you add enough heat and they move quickly enough, then the molecules break free and begin to escape into the air, which would be the water vapor that we've been talking about. Okay, there is a form of evaporation that can happen in plants. It's called transpiration. This is when the plants, they soak up the water from the ground as a liquid, and then after using it for photosynthesis, they actually release the water vapor directly into the air. So there's a little bit of evaporation that happens through the plants, but most of it is with the sun heating up lakes and ponds and oceans and streams and things like that. All right, that's our first process, evaporation. Next, we have condensation, okay? So evaporation is taking the water from a liquid to a gas, okay? Condensation is the opposite, going from a gas to a liquid, all right? Condensation is the process in which water vapor changes into a liquid, all right? Well, we said before, the evaporation can only happen by adding heat. How do you think condensation happens? Well, if we're doing the reverse process, the only way we can get condensation is if the water vapor cools, okay? Heating causes evaporation. Cooling causes condensation. Condensation is the process in which water vapor changes into a liquid, and it occurs as air with water vapor in it cools. Okay, here you can see this would be like an example of if you take a cold can of Coke from the fridge and put it outside in a hot summer day, eventually you're going to see it begin to what we call sweat, right? These water droplets begin to form. What's happening is the water vapor in the air, right? The humidity that we talked about with those weather factors. When you put the cold can outside into the heat, those hot water molecules that are floating around in the air, they touch the side of that can and they instantly begin to cool off. Well, when you get enough water molecules that cool off at one time, a water droplet forms, okay? Which eventually they pool up and you see more and more droplets on the sides of the can. The more humid it is outside, the more condensation you will see on the can. Same thing here with the window. The best way I can describe this is if you take a hot shower, again, and you come out and your mirror is all fogged up, you know what I'm talking about, okay? The water molecules that you release into the air from your hot shower, okay, right? All that humid and fog, okay? When they reach the mirror, that piece of glass is a lot cooler, okay? So the water molecules that are warm and floating around, they reach the mirror, they cool off, and they condense and form into a little water droplet, okay? That's condensation. It could also occur in your car. Maybe in the wintertime, you turn the heat on inside the car, and then you see condensation on the windows because it's so cold outside. That's another example as well. Now, when condensation happens in the air, enough condensation of it, also mixed with some dirt and other gases in the sky that we don't necessarily have on the surface, it will form clouds. Okay, this is when water vapor cools and condenses into tiny liquid water droplets. So we have the hot air. I'm just thinking my little pointer or my drawing thing here. Okay, so this is the water here in the ocean, right? So the sun's beating down, the sun begins to heat it up, and eventually those water molecules break free as steam and float up into the air. Well, once they get all the way up here, okay, they begin to cool off and they form back into water droplets. And then eventually you get enough water droplets that come together and they eventually will build up into a cloud. Once that cloud gets more water droplets in it than it can hold, then it will rain and the water will fall back down to the surface again. And then the last part of the water cycle is precipitation. Precipitation occurs when water, or any form of ice, falls from the atmosphere, aka the sky, to the Earth's surface. Okay, so when water or a form of ice falls from the sky to the surface of the Earth. Precipitation forms when the water droplets in the clouds grow and become too heavy to stay in the atmosphere. Okay, so precipitation is when the water forms, it gets too heavy, and eventually it falls as rain, snow, sleet, or hail. Okay, that's what this picture shows you here. Remember that precipitation is any form of water. It does not have to be liquid. Some examples include rain, that is the liquid form. Then we also have snow, the frozen, like kind of softer frozen form. Sleet, which is kind of like I say, slushy rain, a little bit of ice, a little bit of water. And then hail, which is just big chunks of ice. Okay, all of these are forms of water. Some are frozen, some are not, but they're falling to the Earth's surface, which would be considered precipitation. Okay, and then this kind of moving graphic here I like to show because it shows you the amount of water falling throughout the year. You can see it's kind of ticking through the different months of the year here. But what I like to point out is I want you to notice where's the most rainfall. Okay, now look down here at the point. Where's my little guy? Here it is. Okay, look down here at the key. All right. The more white areas have around 0 to maybe 20 or 30 millimeters of rainfall in the month. Green has a little more rain. Light blue has a medium amount of rain. And then dark blue areas have a lot of rainfall. Okay. Now, notice that in the middle of the chart, there's this big kind of thick blue band that runs across the whole middle of the screen. Now, why do you think there is more rainfall around the middle of the Earth than on the upper or lower parts of the Earth? Well, if you think about it, in order for there to be rainfall, it has to be warm enough for that water to evaporate and form the clouds. And all along that middle line there on the map is the equator. And we know that around the equator, things get very, very hot. Okay, right in this middle here, you've got like the Caribbean, Jamaica, Brazil, southern parts of Africa, the Philippines. Okay, all areas that we know to be pretty warm. Okay, so that's kind of explaining why there's so much rainfall in the middle part of the Earth there, because it's so warm that there's so much evaporation happening that it causes a lot more rainfall. Now, for the end of our lesson today, we're going to draw in our notes our own example of the water cycle. I'm going to post that in the next video, but you are going to add that into your notes on your own.